Hello and welcome to 1.1b Inequality. Most of the time in mathematics we're talking about equality, so this is a little bit of variation. Now we get to take a look at when things aren't exactly equal, we want to know how they compare. Okay, let's get started. Here are the symbols that I think many of you probably already know. Obviously this one is equal to, or you can say equals. This one, when it points to the left, you would say is less than, and a variation on that theme, when it has the little line underneath it, it means it can be less than or it can equal. Likewise, over here on the right, when you put a slash through that equal sign, it indicates it's not equal to, or you can say it does not equal. And then in the next one, when the arrow is pointing to the right, we read that as greater than. And again, a variation on that theme, when you add that little line, you've got more choices. You can say it's greater than or equal to, and if the numbers satisfy either one of those statements, then it's correct. Okay, remember from our number line, the number to the right, so as you go this way, the numbers get bigger. So if you find a number here, you automatically know that it's bigger than any number to its left. Likewise, any number, let's change the colors, any number here, if it's to the left, you know it's less than any number to the right. So I point out the number line because, especially when we get to negatives, it's easiest to put the numbers on a number line to decide if it's less than or greater than. You've got to be a little bit careful, especially when it comes to negatives. Okay, let's see what we've got here. So I think you will agree, how would we read this? 10 is greater than 3. Is that true? Oh yeah, 10 is bigger than 3. Likewise, equivalent to saying that would be 3 is less than 10. That's also true. So we can make that comparison in one of two ways. One thing that I found has helped students in the past remember which way to point that arrow. The smaller end of that sign is going to point to the smaller number, and the bigger end is going to be associated with the bigger number, and it doesn't matter which way it points. The bigger number is always going to be at the bigger end, and the smaller number is going to be at the smaller end. Another way to think of it, the inequality always points at the smaller number. Okay, let's take a look at some examples. Up here, let's see if these statements are true or false. Does 5 equal 5? Well, I'll do that one. That's pretty easy. How would you say this? Next one, 5 is less than 8. Do you agree? Yep. 5 is less than or equal to 8. Well, clearly 5 is not equal to 8, but like I said, if just one of those is true, then the whole thing is true. So I'm going to put that less than to indicate that 5 is less than 8, so that whole statement is true. I love this last one. What do you think about that? 5 is less than or equal to 5. Well, 5 is clearly not less than 5, but it is equal to, so that is still true. Over here looking at the same way, obviously 8 doesn't equal 5. I'll do that one. 8 is greater than 5. Yep, I agree. 8 is greater than or equal to 5. Yes, it is. It is greater than, so that's good enough for me. And 8 is greater than or equal to 8. Yes, because that equal sign means we can accept that. Okay, let's do some true and false. What would you say about this first one? 10 is greater than 2. Yeah, true. Okay, the second one. Negative 10 is greater than a negative 2. Oh, I hear you. Half of you out there saying true. Be really careful with those negatives. I'm going to have to do a little, I'm just going to turn this line into a number line, and let's take a look at that. Where would we find negative 10? If this is 0, where would we find a negative 10? Well, let's just say way down here. So negative 10, negative 2, well, that's just 2 to the left, so we've gone further to left with our negative 10. So which is bigger? Yeah, the one to the right is the bigger number. So negative 10 is not bigger than negative 2. So let's put an F. That's false. Is 2 bigger than a negative 10? So again, think of your number line, where 2 would be and where negative 10 would be. 2 is going to be to the right, so it's bigger. We'll say true. Negative 2 greater than a positive 10. Think of where those are on the number line. Nope. That's going to be false. And finally, negative 2 is greater than a negative 2. No, because negative 2 is not to the right of negative 2 on the number line. It's at the same place. So that right now is a false. Could we just change this middle symbol a little bit to make that a true statement? Yeah, if we include the option equals, then we can turn that statement into a true statement. Okay, very quickly. Over on the other side, using less than. 2 less than 10? Yeah, true. Negative 2 less than a negative 10. I didn't fool you so many this time. No, it's false, because again we can see on the number line, here's negative 2, and here's negative 10. Negative 2 is not less than negative 10 because it's further to the right, so that's a false. Negative 10 less than negative 2, negative 10, to a positive 2. Yes, it's less than because it's to the left. 10 less than a negative 2, oh no. And 10 less than 10, false, but again, I just can't resist this. I want to be able to make this a true statement by just changing that symbol ever so slightly and including that little equals or equals, and that then becomes a true statement. Okay, next ones. So in this examples, we're going to just confine ourselves to these 3 symbols. So we're not going to give ourselves any options with the or equal to. So I've got number lines by each problem. So one thing to think about, even if you don't put it on paper, think about it. If you've got 2 points here, and those 2 points have to represent negative 8 and 1/2, who is down here? That would be the negative 8, and then up here, 1/2. It doesn't matter where 0 is or anything, we're just getting them relative to each other. So what's your answer? Negative 8 is less than. And again, remember, that arrow points to the smaller number, and this shows us negative 8 is the smaller number. Next one, negative 8, negative 15. Well, relative on here, so they're both negative, so we know 0 is up here somewhere. Negative 8 versus negative 15. So the negative 8 says we've gone left 8, and the negative 15 says we've gone left 15. So we can see this is going to be the negative 8, this is going to be the negative 15, which is the smaller number, negative 15, because it's further to the left. So we know our arrow should point to that negative 15, and then when we read that, we can say negative 8 is greater than negative 15. Next one. 1, negative 219. I hope we all have, there's our negative 219, and there's our positive 1, which is smaller, the negative 219. So our arrow is going to point to that, and we would say 1 is greater than negative 219. Uh-oh, the last 4. I don't have any numbers other than 0 in the first 2 examples, but I've got question marks, but we do know the sign. So we're comparing 0 and a negative. So on the number line, all of our negatives are to the left of 0, so that's going to be the negative number to the left, and that's 0, which is the smaller of those 2, the negative, whatever it is. So we point that arrow to that negative question mark. 0 is greater than any negative. Okay, next one. 0 is what compared to all the positives? Well, the positives are all to the right of 0, so that means that's going to have to be 0, and that's going to be the positive who knows what. The smaller number, 0, so our arrow points to that. 0 is less than any positive. And then finally, comparing positive to the negatives, I think you will agree. Any positive is going to be greater than any negative. Likewise, any negative is going to be smaller than any positive. Okay, I will see you in the next section on absolute value.